Our next video here is about the law of cosines, and we're trying to solve oblique triangles, meaning we don't have a right angle, just a triangle with no right angle. When we use law of sines, we needed an angle and its opposite side, or I was calling it a pair, an angle and its opposite side. In this case, if you have side, angle, side, or what we'll do next video, side, 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 you do not have a pair. So you can use what we call law of cosines. And as three forms, this is one form here. It's very similar to the Pythagorean theorem. If we were to just lose that piece, it looks like Pythagorean theorem, c squared equals a squared plus b squared, and then minus 2 times ab cosine c, where ab are those two sides that are on this part of the equation, and cosine of angle c is not those two sides. So again, the Pythagorean theorem actually is a very special form of the law of cosines, just when you have a right triangle. Here are the alternate two forms. We can have, if you want to solve for side b, it'd be b squared is equal to the square of the other two sides, a squared plus c squared, minus 2 times these two sides, ac, times the cosine, because the law of cosines, of which angle? Well, it's not these two sides, so it's the other angle, cosine of b. And then our third form, solve for side a squared equals b squared plus c squared, minus 2 times those two sides, bc, times the cosine of angle, not b or c, must be angle a. And there's our law of cosines. First problem here, we're going to solve given this information. Remember, solve means you find all pieces of the triangle, all angles, all sides. Given a equals 2, b equals 3, c equals 60. Now you might eventually get good and realize that side A, side B, and angle C, you can recognize that's going to be side, angle, side. But kind of takes a while to figure that out. I always suggest to draw your starter triangle so you can see what pieces of information you've been given. So let's see a 60-degree angle, I don't know, it's about 60 degrees, and let's do something like that. I don't know, that's good enough. Let's go, and let's say this is side C, side B, side A, call it 60 degrees. A is 2, B is 3, don't have side C. So you look at the information again, okay, I have a side, and then an angle, and a side consecutively. You can't go, it's not side, side, angle, no, it's consecutively. Side, angle, side, side, angle, side, you can use law of cosines. Cannot use law of sines because we need a pair, we need this side. So, the only side I can solve for is side C. So, c squared is equal to a squared plus b squared minus 2ab cosine of angle C. C squared is equal to a is 2 squared, plus b is 3 squared, minus 2 times 2 times 3 times the cosine of 60. And we got 4 plus 9 minus 12. Cosine of 60, that's a special item. Cosine of 60 is 1/2 times 1 over 2. 13 minus 12 divided by 2 is 6. C squared is equal to 7. C is equal to the square root of 7. Okay, square root of 7. Now, we can use law of cosines again. Law of cosines again will work just fine. If you want to find side A or B, we just know all this part, we won't know the angle, so we use inverse cosine. However, we now have a pair. We have an angle 60 and its opposite side radical 7. You can use law of sines if you want. Law of sines is easier. However, you want to make sure the angle you're looking for is acute. We're solving for angle A or angle B. In a triangle, you could have one obtuse angle, mean bigger than 90, but there can only be one obtuse angle, which means it's going to be the opposite the biggest side. I'm going to say that again. If the angle is obtuse, it must be opposite the biggest side. 3 is bigger than 2. So if we solve for angle A, we are guaranteed that angle A will be an acute angle, and it makes the law of sines better. Because if you find the law of sines for an obtuse angle, you can get multiple answers. But we know angle A must be smaller than 90 because it's opposite of side that's not the biggest. So the law of sines right here. sine of A over 2 is equal to the sine of 60 over rad 7. Sine A equals 2 times sine of 60 over rad 7. Calculator, you get, where did I write it here? Well, you do, let's go. Okay. 2 sine 60 divided by rad 7. Get sine of A is equal to 0.6547. So inverse sine to find angle A. Get A is equal to 40.9. Now, in our previous lesson, we said the sine of A equals 0.647. It has two answers because sine can be positive in first or second quadrant. But we know A must be an acute angle because it's opposite a smaller side. So 40.9 degrees here. What's left is to solve for side B, or sorry, angle B. There's 180 degrees in a triangle, so 180, or sorry, angle B is equal to 180 minus 40.9 minus 60. Angle B is equal to 79.1 degrees. That's it. Here again, we've been given two sides and an angle. Let's draw our triangle. So B is 10 degrees. It's kind of a small angle, so we've usually been putting B at the top. So let's see here. Let's make angle B very tiny. Means we'll probably need a bigger angle here. So that A, B, and C. Alright, A is 2, C is 1, angle B is 10 degrees. So we cannot use law of sines because we do not have an angle on its opposite side. We use law of cosines. We can solve for side B because we have side, angle, side. B squared is equal to A squared plus C squared minus 2 times A times C times the cosine of angle B. Side B squared is equal to A squared 2 squared plus 1 squared minus 2 times 2 times 1 cosine of 10. See, this is 2 squares is 4 plus 1 squared is 1, 4 plus 1 is 5 minus 4 cosine of 10 degrees. Go calculator here. 5 minus 4 cosine of 10, and we get 1.0608 square root both sides to get 1 point, and we've been rounding to the 10th place to get 1.02 something, which rounds to 1.0 or 1. Okay, so this side is about 1.0 or 1, which would mean you think, oh, this is an isosceles triangle. Technically, B is a little bit bigger than 1, so it's not technically isosceles, but that would mean that this angle would just be a little bit bigger than 10, but we're rounding to the 10th place, so that's how we're going to round. B is 10. Or sorry, B is 1. Now, we have an angle and its opposite side. We can start finding these other angles. You can use law of cosines, or we can use law of sines if we know that it's going to be an acute angle. If we find angle C, it's opposite of side C, which is 1. 1 is less than this side, which means that angle C must be acute. Law of sines will work. Let's go right here. Sine of angle C over 1 is equal to the sine of B, which is 10 degrees, over side B, which is we rounded to 1.0. Well, sine C over 1 is just sine C equals sine of 10 over 1, which is a sine of 10. There you go. The sine of some angle is equal to the sine of 10 degrees. Well, C must equal 10 degrees, or about 10 degrees, right? Because we rounded, but it's okay. C is going to be 10 degrees. We have two angles, we want to find the other angle. Let's see, 180 minus 10 is 170, minus 10 is 160. A is 160 degrees. And we're done.